In this section, we're talking about intervals where the function is increasing and decreasing, and we're talking about local, max, and min. And you have your notes on this page. Of course, you can print these out from the blank notes and completed notes as well. In this first problem, I ask you to find where the function is increasing or decreasing, and then find all local extrema. Sometimes they use the word relative, but in this particular textbook they use the word local. So your steps start like this. You'll see your steps on the previous page. The first thing you want to do is find your domain of f. Okay, so your domain of this function is all real numbers. Of course, it's all real numbers because it's a polynomial. So we're going to be taking a number line of all real numbers. Okay, step 2 tells us to find the critical numbers. There's step 1. Step 2 tells us to find the critical numbers. So the way that we do that is we see where our derivative equals 0, and we see where our derivative does not exist. We don't have a denominator, so we don't have to worry about the does not exist part. My derivative of this function is 3x squared minus 3 plus 0. So it would be 3x squared minus 3. I'm going to set that equal to 0. Now there's two different ways you can solve this blue equation, this derivative equation. You can use the square root property, or you can solve it by factoring. I'm going to solve mine by factoring, but do make sure that you know you're going to have two answers because it's an x squared equation. So the first thing I notice is they have a 3 in common, so I can factor out that greatest common factor. And then it's just the difference of squares. So the 3, I could divide both sides by 3 and it goes away. The x plus 1 equals 0, and the x minus 1 equals 0. So my two critical numbers are negative 1 and 1. So what it tells you to do once you find these critical numbers is mark these on the number line, dividing the number line into intervals. Now the spacing is not important, but the ordering is important, so make sure that negative 1 is to the left of 1. Okay, so that brings us to step 3. Step 3 says choose a test point from each interval. You can pick any number that you want that lies in that interval. For over here, I'll pick negative 2. And for here in the middle, I'll pick 0. And over here on this side, I might pick 5. You can pick whatever number that you want. You can pick 2 or 3 or 4 or 100 if you wanted to. Any number in that interval. What you're going to do with those green test points is you're going to substitute the test point into the derivative. So my derivative is 3x squared minus 3. So I'm going to plug these three green numbers into 3x squared minus 3, and I'm going to look at the sign. Okay, so I'm going to 3x squared minus 3. My first digit to plug in is negative 2. That gives me 12 minus 3, which is 9. What's more important to me is that it is positive. Okay, when I plug in 0, let me write my function again. Okay, remember you're plugging into the derivative. That's an important part. Plug into the derivative. So that's 3 times 0. This test point is 0. So I get 0 minus 3, which means this one is a negative 3. More importantly, it's negative. And then I'm going to plug in 5. That gives me 75 minus 3, which is a positive number. Now, so that's step 3, choose a test point. Now reading through there, the next part's really important. It says, if the sign is positive, you are increasing. Well, it works out for me if I draw that as an increasing line. If the sign is negative, it's decreasing. And if the sign is positive, of course it's increasing. So this allows me to go ahead and write those answers. It's increasing from negative infinity to negative 1, and it's also increasing from 1 to infinity. The textbook gives you the definition of increasing and decreasing functions as open intervals, which means that you get to use parentheses. So you don't have to struggle with brackets or parentheses, you just want to use parentheses here. It's decreasing in the middle, so it's decreasing from negative 1 to 1. So that solves the first part of it. But then you have to decide, do you have a local max or a local min? Well, let me show you a little trick. Let's see if I can find a fancy pen here. Here we go. Let's not find a fancy pen, sorry. Okay, so let's go back to my number line for just a second. See how this one goes up and then it falls down? So if it goes up and then down, that makes a max. And see how this one goes down and then up? That one makes a min. Now you have a definition for that, or points for that, on the previous page. It says if the derivative changes from positive to negative, you have a local max. If it changes from negative to positive, you have a local min. So you can memorize the rules that you have, but I think it's a lot easier if you just follow the arrows. So see how it goes up and then falls? That means at negative 1, I have a max. See how it goes down and then back up? That means at 1, I have a min. And that's how we would do that one. Now, you also have to go back in one final thing and find the y value. Well, there's one really important thing you'll see on the previous page. It says to find the y value, always plug into the original. So when I get ready to find these y values for my points, I'm going to plug into the original. The original function is f of x equals x cubed minus 3x plus 4. Anytime I ask you to find y, you're always going to use the original. So my first function was f of negative 1. If I plug in negative 1, I get negative 1 cubed minus 3 times negative 1 plus 4. So that's negative 1 plus 3 plus 4. So I think that should give me the value 6. So negative 1, 6 would be a max. My second critical number is 1. If I plug that one in, I get 1 cubed minus 3 times 1 plus 4. So I get 1 minus 3 plus 4. So putting that together, that's 5 minus 3, which is 2. So I have a min at 1, 2. And that's how that part would look.